Hello, my name is Jeremy Garza. I'm with the Department of Biotechnology at Austin Community College, and today I will be reviewing with you the general operation of the Biorad Duoflow FPLC system. There's 8 basic operations that we're going to review, some in more detail than others, but we're going to start with the buffer preparation. I'll give you a quick overview of that and how we have to, once we make our buffers, you'll want to filter and degas them. And then we'll show you how to start the system. And then once you've got the system started, we're going to show you how to prime and purge the system. So that will be how we introduce mobile phases into the system. Now currently the system is sitting in 20% ethanol. That's how we keep it for long-term storage. So I'll be rinsing out the 20% ethanol and flushing it with water. So the demonstrations today is going to be with water, but these steps will apply to any mobile phase that you may use. So we're going to flush the system. I'm going to show you how to find the pH electrode and where in the software you can go to calibrate it. And then once we've done all that, we will equilibrate the system, and specifically we mean the column. So the entire FPLC system is designed to operate around the purification column itself. So everything you see here, the heart of it is the column here. And that's essentially flushing the system with the running buffers you will use for your purification. So you've got the system equilibrated, then we're going to walk through how to set up a protocol and run a purification. And then after that's done, you'll want to shut down the system. So the first thing we're going to review is how to turn on the system. So I've got the computer turned on here, but before you open the software, I want to power on all of the individual modules. So I'll power those on, and then I'll walk through and give you an overview of what each of them are. There's 2 hard switches here. This is the pump and the maximizer. These 2 work in concert with one another. And this is our fraction collector. The switch is in the back. All right, so we'll give these a minute to turn on and initialize, and while that's happening, I'll give you a brief overview of the system. So here we have our buffer tray. This is where our mobile phases will sit. You can see here we have our inlet lines currently sitting in the 20% ethanol. Our inlet tubes are here, so this is where we'll draw liquid in. See all of our inlet lines submerged there. The mobile phase will be drawn in through the inlets. I enter the maximizer. It's 4 ports, A1, A2, B1, B2, and they travel up through each of the pumps. Next, and then here we'll enter into the mixer, where the system will has a little stir bar where this will make sure it's homogeneous. And then here's our inject valve. Again, this is a 7 port, 3, 4, 5, 6, 7, 7 in the back. 7 ports and then 3 positions. And here you can see a diagram of the different positions. I would recommend looking at these diagrams closely if you want to get a better sense of how the system operates, because it's basically flowing in from our mobile phases and out at our fraction collector. But how it makes its way through the rest of the system can be determined by looking at these diagrams, and specifically look at port 5, the pump, because each one of the positions, the pump is being diverted in a different way. So take a look at those, and it'll help you get a better understanding. So we're going to go ahead and travel down line. So here's our sample loop. This is where the protein sample sits. So if you remember, this system basically automates our purification. We're going to load our sample onto the system, and then we're going to push start, and the system will run the entire purification for us. Right, but this is where our sample sits here. This is a 1 mil column, loop. Here we have larger 5 mil loop, and these just go up in size. So we'll continue down line here to our column. So this is this is a pre-packed column, 1 milliliter. Just for comparison, this is a 5 milliliter column, so there's 5 milliliters of resin packed inside these columns. You can buy these directly from the manufacturer. And then we'll just keep following to the detectors back here. So this housing contains the UV detector and the conductivity meter. See here, there's a filter, 280 nanometers, standard for proteins. There are other detectors that you can measure additional wavelengths. And then the sample will continue flowing through the UV detector into the conductivity meter, again, which measures salt. Essentially, the more salt you add, the more conductive the mobile phase would be. And then here's our pH probe. I'll show you how to access that and get it calibrated. And then we follow the rest of the flow path down here. This is also a small diverter valve. So right now we're just going directly to waste, but once we start doing our runs, we'll set up the software to divert to the fraction collector here. Here's where all our tubes will sit and collect the fractions throughout our purification. And this is grayed out, but just to remind you, this is the manual interface. There's a few different interfaces you'll see as we go through this, but we're currently in the manual interface. But this is the pump control area. You can see here the mode, this system and local. So if you're going to control things at the system, like when we're purging and switching the pumps, you want to switch it to local mode here. If you're controlling it from the software, you want to make sure it's in system mode here. It's in local mode. You'll notice that this gets grayed out and you can't really see it. So in system mode, you'll see that it's now accessible. But you can find set options like flow rate in milliliters per minute. So the flow rate specifications are given to you with the column instructions. So if you look up the specs on the spec sheet, it'll tell you what the maximum flow rate will be. And down here, it's also going to tell you in the spec sheet what the maximum allowed pressure for the column is. So in this case, we have a 1 milliliter column, which has a max pressure of 45 psi. But the reason it says 85 psi on the software as our maximum is because we have a back pressure regulator located just after our pumps and the flow path. So that adds an additional 40 psi. So together that gives us a nominal max pressure of 85 psi here. But again, whatever column you have, look at the spec sheet, and whatever the listed maximum pressure is, you'll add 40 psi to that, and that will be your pressure maximum setting on the software. And as long as you have this set, there's not really much you can do to damage the system, so don't worry about that. Again, just make sure your pressure limit is set. If there's something wrong or a clog happens, the system will shut itself down and let you look at it, and it won't continue to operate and possibly damage anything. We'll see our pump controls, so A1, A2, B1, B2, they're kind of cut off, but that's what they are. And then the composition. So if I want to do 50% A1, 50% B2, I'll just switch A1 here. So now A1 pump inlet line is active along with B2, and then vice versa. You can do inlet A2 and B1. And then if I want 25% from the A pump, you'll see as I make that switch, inlet B will automatically adjust. Once we set our flow rates, let's do 2 milliliters per minute. We can push start, and you'll see the little icon starts running. So while our pump is active, if we wanted to make some changes, so return to a 50-50 ratio, you can set it, but it won't take place until you actually push the set button. Okay, this is our fraction collector area. We can control the fraction collector manually here. Let's say, for instance, I just want to collect a little bit of water to make sure that it's working. I will set where I want it to start, so position A1 in the rack, and where I want it to end, again A1 in the rack. And then the fraction, I'll do 2 milliliters of volume, so I'll push start, and then the fraction collector will begin moving the arm and collecting that fraction, and then once it's done, it'll return to the home position. Okay, so that's how you control the fraction collector manually. We also see we have a manual control interface for the UV detector here. So it's on, so the on button is grayed out, but it can also be turned off, for instance, when you're shutting down the system. There's also a zero baseline button, so it's essentially blank, allowing us to blank our system. Here in the center we have our workstation valve controls. So you may not see them, but if you push the drop down arrow, it will show the inject valve that we have, AVR 7-3. Again, it's 7 is the number of ports, 3 is the number of positions. So here's our 3 positions: L for load, I for inject, P for purge. And at the bottom here, we see a small chromatogram. So this gives us live data. So you can see on the left we have milliabsorbance units or absorbance units. Also, you hear people say milliabsorbance units or mol. It's basically reporting how much absorbance the system is detecting at 280 nanometers. It doesn't always necessarily mean protein. It just means that it detected something at 280 nanometers. Protein does generally absorb there, but there are other things like salts that are used in chromatography that could also absorb at 280 nanometers, so just keep that in mind. And on the right, we have conductivity access, which is the red trace. You can kind of see it here. The blue trace is just above it, and then the black trace here, that's our percent B, which we're currently sitting at 75. So if I switch this, for instance, to 0B, or let's say 20% B, you'll see it drops here down to 20%. So you can take these axes and you can zoom in on them, right? So if you look at the axis here, zooming in, this is our UV trace, the blue one. So if I go to zero baseline, press it, you'll see that it drops down and zeroes itself there. So it wasn't immediate. Give it a second or two between the commands and what you might see. And then some other menu options here. So across the top, these are kind of quick navigation buttons. A lot of these menus can also be accessed through the file menus at the top. Utilities, this is where you'll find system and diagnostic information, and also if you want to calibrate anything on the FPLC itself can be done here. So there's our pH probe calibration. Options, so again, this is where you can change preferences and settings. Buffer blender setup, so a lot of times we'll run our systems manually, but you can also have it to where if we just put a conjugate acid and base in our system, so tris hydrochloride and tris base, we can just tell the software we want it to run at a certain pH. Instead of trying to figure out or make a buffer that's at that pH, it's going to automatically calculate and determine how much of each of those conjugate acid and base are required in order to achieve that pH. So I can show you that real quick. So buffer blender setup can be accessed here. Again, these little quick buttons here. So we'll open our buffer blending setup menu again, and we're going to turn it on. So depending on what system you use, there's a lot of presets. We usually use tris system, and then down here it's going to tell you what the recipes are and also which line to put the buffers on. Well, we've got our buffering system selected and we've checked the box for use buffering blending. So watch how this changes here when I push OK. Alright, so our flow rate's still there, our pressure limits are still there, but we've changed the way we control the pumps now. So now we just tell it what pH we want. Software will make the changes automatically. And then if we want to increase the salt, we change percent B here. Our salt is on line B2, for instance, so we just change what percent we want, push set, and then pump B will automatically start drawing 50% salt into our mix. And then one other thing I want to point out on the software is you can't see it here, but let me move the window a little bit. Okay, so at the bottom here, you're going to see
live values. You're going to see what the determined value or the flow rate is. So here it's 2 milliliters per minute, and it matches what we have up here. Percent B2, right? 0%, which it's set at currently. It's also going to give you, and this is most important, it's also going to give you a live pressure reading, right? So we have our pressure limit set here, but at any point in time you can look at the bottom and see what the current system pressure is. And then we also see here the live reading for the UV. So we're right now just pumping water through it, so we don't have anything absorbing. It's also been zeroed. And here you'll see a live value for your conductivity, so 0.512 millisiemens per centimeter. And at the far right, we have our current pH reading. So it's giving you a uncalibrated reading currently. But once you add your buffers in, you'll see, and the pH meter has been calibrated, you'll see that it should match what your setting is.
All right, so now that our system has been started, next thing we'll do is show you how to prime and purge the system. So when we're priming, what we're doing is we're drawing in the new buffer into the inlet lines. All right, so the first thing I'm going to do is I'm going to take the tubing out of the ethanol, and I'm going to put it into our filtered and degassed water. All right, so I'll prime the system, and to do that, I'm going to take a 60 milliliter syringe, and at the front of each pump there's a priming port. So I'm going to place the barrel of the syringe onto the port, and then I'm going to open the port, and I'm going to slowly draw 10 to 20 milliliters of my mobile phase through the syringe. You may get some air bubbles trapped in the inlet lines when you switch over between bottles, so that's another reason we want to prime. But once you draw the air bubbles out, you shouldn't see any more. So I'm going to draw on this 10 to 20 milliliters. You're going to feel a good amount of resistance, but just keep pulling. And once that's done, close the port, and we'll pull off the syringe. There's a waste container here that I'm going to put that into. And then now we have to do the second port on the first pump. So this is port A1. Now we're going to do the blue line, which is port A2. I can switch to port A2. I'll repeat the process, and then I'll repeat that on side B.
And the other side. I'll place the syringe on there. Should be pretty snug. Then twist at the port here. Turn, and then I'm just going to withdraw 10 to 20 milliliters. There shouldn't be any air coming out. Should not. So we'll stop that. Close the port. And then remove the syringe.
Okay, now that our system has been primed, so we've basically drawn in our water, flushed the ethanol out of the inlet lines up to the maximizer and here at the pump. So now what we want to do is purge the pumps. So that's going to run them at maximum capacity for approximately 30 seconds. So in order to do that, it's very simple. We'll just push the buttons here that are labeled A and B. It also says purge right above them. So we're going to push those, again, making sure before you do this that the inject valve is in the purge position. And if you're unsure, there's a small window here with the letter P for purge, so you can double check there. Also, you can check in the software, but you can visually confirm here on the module itself. So we're going to push these on, and you'll see that the LEDs for pumps A and B will start blinking, indicating that the pumps are purging. What we want to check for is that there's a steady flow at the waste end, at the waste line.
So here we can see that we have a steady stream of our water that we're flushing through the system coming out. If there was a weird pulsations or there was air bubbles come out, we would just continue to run. But once you've purged for approximately 30 seconds and you've confirm that there's a steady stream of liquid coming out, we'll go ahead and pause, and then we'll do the other 2 inlet lines.
Okay, so now it's been about 30 seconds, so I'm going to press the A and B buttons again. You see the LED indicators are deactivated, so the purging has stopped.
So here we can see that currently A2 and B1 are activated, so we'll push the port select buttons. That will activate the other 2 ports that we have not purged yet, A1 and B2. And then we'll go to the pumps here, and you can press these buttons, and you'll see that the pumps are now purging. So once we've purged for 30 seconds, we can push the purge buttons again, and it will stop.
Now what we want to do is flush the system. So it's been stored in 20% ethanol, and flush the rest of the system with water to remove any of the ethanol.
Okay, so now that our system's been primed and purged with the water, what I'm going to do now is show you how to flush the 20% ethanol out of the rest of the system. And in order to do that, we'll go to our pump control module. So we're currently in what we call buffer blending setup, but I'm going to turn that off and return to our individual manual controls. Alright, so you can see our valves are currently, our valve is currently in the purge position. So we can start the flow. Here we've got our pressure limit set, and we're going to start with the flow rate of 2 milliliters per minute. Make sure that we're in the system control mode. Alright, so what I'm going to do now is switch to the load position. So we'll just click the button. So I've pumped a little bit of water through the load position. Now I'm just going to change the valve to include the sample loop. So the sample loop, remember, also is sitting in 20% ethanol. We want the whole system sitting in 20% ethanol while it's stored. And now we're going to flush the sample loop out with water. So while the system's flushing, it's also still in the process of warming up, and we want to pay attention to these traces here. One other thing we do want to look at is our UV trace. When we're flushing, our UV trace to be as stable as possible. So we'll give that, a couple more minutes at least to stabilize, and that's that for flushing. This is the same process when you switch over between any buffers. So if we're sitting in 20% ethanol and then we're switching over to water to flush the ethanol out, we'll repeat this process. And then the same thing when we go to equilibrate, right? Our system will be in water, but we want it to be in our tris buffering system. So we'll repeat this flushing process. Okay, so we've now flushed our system. And next thing I'm going to show you how to access the pH electrode itself, and then where to find the calibration wizard on the software. All right, so our pH meter is housed here into this probe. All right, so I'm going to show you here how to access the pH probe. See, it's here in this beige housing. So we'll make sure that the flow is stopped, and then in order to access it, we're going to remove or unscrew the ring here. So that should unscrew by itself. All right, I'm going to pull that up, and then we can remove the pH probe. And that's what we'll rinse and then drop in our pH standards. In order to replace it, we'll just put the probe back in, make sure it's seated properly, and then screw back down the probe. So now I'm going to show you how we calibrate the pH meter. Go to our utilities menu, and you see here we have pH probe calibration. Click that. It's going to open our calibration window. And just give you the instructions here. The purpose of this calibration is to calibrate the pH probe. Press start to continue. Calibration has been completed. And now we can exit or repeat the calibration by going to start.
Okay, so now that we've gone through and showed you how to calibrate the pH electrode, next thing we want to do is equilibrate the system. And so we're going to flush now the water out of the column, and we're going to equilibrate it with our running buffer. So for that, we'll just show you how to do that on the software.
What we want to do is put the system in the buffer blending mode. And so to access that, we can go to options, buffer blending, or you can go to this little quick button here with the multicolored icons. Check the box for use buffer blending. We're using Tris 25 millimolar. So I'm going to push OK, and then again pay attention here to the pump control menu and how it changes once we've got buffer blending selected. And it gives us a box to input pH value. So if I want to change to pH 8.1, I just put in pH 8.1 here. And then now we can control inlet B. So we're still controlling pump A and pump B. It's just the interface is different. Pump A, we're telling it what pH we'd like. And then here we're still controlling inlet B. Okay, so we want a pH of 8.1 to equilibrate, and we don't want any salts, at least not for now, so we're going to push start. Once we've established that the flow is running okay, what we want to do is charge our column. So we're going to set that to 100% and then press set. Since it's running, we're going to push set to apply the changes. And we'll continue to do this for 5 to 10 minutes, or about 10 to 20 column volumes. Once we've run our system with 100% salt, we'll return it to 0% salt. Push set. So our column's been charged with salt, and now we're just going to return the system to 0% salt. So our system is now equilibrated. Okay, here I'm going to show you how to build the purification method. We're going to use this one here. So again, here's our browser menu. We can see we have our users, and then each user will have, project folders, and within each project you will have purification methods, so anion exchange, and then each method will have several runs. So this is our folder. I'm going to add a new project to this user, and I like to name all my files beginning with the date, and I do the date in reverse order, year, month, and then day. It is an ISO standard 8601, so I advocate for that. It becomes really helpful once you start to build a lot of files or have to catalog a lot of samples. It's just a quick and easy way to find what it is that you're looking for on a computer. So I usually try to put that at the beginning, and then I will name this example 2. Because I already have one example, so I'm going to name it example 2. Alright, so you can see now we have a new folder, but we don't have the plus arrow because we don't have any methods, right, like this one does. So we're going to right click on our project folder, or you can go here to new, right, do new method. I'll name it the method type. So we're doing anion exchange, and IEX is shorthand for ion exchange. So once you've created your method, it's going to go through 3 windows here. The first is the device setup. You're going to tell it what hardware is on the system. By default, it has UV detector, conductivity meter. We're also going to add our fraction collector. So push OK. Fifth thing we want to make sure we add is the buffer blender. So we're going to use buffer blending, and then we'll go to the drop down menu, select our system, push OK. Alright, so now we've got our devices set up. Now we're going to go to protocol, build our protocol here. So on the left are all of our commands. Isocratic flow means that we want to maintain, some constant concentration. Load and inject sample. So remember, our sample will be on the loop, and this is the command line to tell the system to push our sample off of the loop and downstream to the column. This is a linear gradient, where our isocratic control maintains the same concentration of our buffer. Linear gradient will increase from 1% to a second percent, and we're going to use that. Zero baseline. So again, this is just a blank RUV detector. There's a lamp control, so we can insert a command to, for instance, turn the lamp on, which I like to do at the beginning of every method. That just makes sure That's just to make sure that if it was inadvertently turned off, when we start our purification, it will make sure to turn it on. And then here is our fraction collection command line, which we'll also add at the beginning. So we're going to just collect all of our fractions, and then we're going to tell it that we want 2 milliliter fraction sizes. So the first step in our protocol is isocratic flow. So we're going to click isocratic flow, and it's going to give you 4 options here. Remember, we're in buffer blending mode, so we're going to tell it what pH you want. We do want 8.1. What percent salt we want, so we still just want 0% salt. What volume do we want to use? So we're going to flow 10 column volumes, or 10 milliliters, since we have a 1 mil column. And then the flow rate, so we're going to use 4 milliliters, which is about the maximum for this column. And we'll push OK, and you'll see the isocratic flow step has been added. And here it's giving you the settings that you put in: the pH, the percent B, what volume, and then the flow rate. So it's going to have that information for every step. Now we want to apply our sample application. We do that by adding a load inject sample command. So again, it's going to prompt us for pH and percent B, which will keep the same. And then what volume do you want to flow for this step through the system? So we have a 1 milliliter sample loop, so I want to flow 2 milliliters. So that's going to ensure that all of that 1 milliliter sample is pushed off of the loop and downstream. And the flow rate, we're going to decrease the flow rate actually to 2 milliliters per minute at this step. And that's just to give our sample a better chance to bind to the column, right? So it starts to slow down the flow. Now we want to start washing. So we'll do that by adding an isocratic control commands. We'll maintain pH at 8.1, percent B at 0. And then we're going to flow 6 milliliters, or 6 column volumes through, at a flow rate of returning to 4 milliliters per minute. So you can see it's been added. So that is our final protocol here. Now that we're ready, we can run our sample. So it's going to open a new box. And again, I recommend putting the date, and then run 1. And I'll put my name or initials here, and then I'll push OK. You'll also notice there's a green start button here at the top, so we don't want to push that yet. Before we start this, what we want to do is actually load our sample onto the loop. Before we do that, let's go back to manual. So that window will stay there. Right, if we return to run, it's still here. There's our green arrow. Right, so that was from run. But we're going to go back to the manual interface. And we want to make sure that our inject valve is in the load position. Okay, so here I've got my syringe that I'm going to use to inject our sample into the system. The needle comes off. Do not throw these away. Please keep these. These are not regular needles. They are blunt-ended needles specific to our instrument. But you will grab a new syringe every time for your sample. So we're going to put that onto our syringe. So I'll place it in our sample, and then be very slow when you're drawing the sample up. If you pull too hard, because of the small opening on the needle, you could cause foam to enter. So again, I'm going to draw a little bit more than 1 milliliter. So now what we're going to do is just remove this little excess air here. So now we can put this on onto our system. Okay, so now this is our sample here. What we're going to do is load the sample loop with our protein sample. So our sample port is located here on the inject valve. We want to make sure that the inject valve is in the load position. If you reference your diagrams for the inject valve, you'll see at the load position. If we take a look at port 2, which is where our sample enters, it's going to enter port 2 and exit port 3, which is where our sample loop is connected. So the first thing we want to do is go to our software, and in the manual mode, right, which we're in, just make sure that our injection valve is set to the load position. So again, we can confirm that we are in fact in load position by looking at our little window. What we're going to do is going in here, and then sample will go in through this port, out through this port, which is where our loop is located. gently place our needle into the injection port, and then once it stops, don't force it any further, and then take the plunger, and you can support the barrel if you want here so it doesn't bend the needle. Try not to bend the needle, and then we're going to slowly push in our sample. Feel a little bit of resistance, but keep pushing, and then once it stops, we'll leave the syringe there and return to the software. Okay, so now we've got our sample load on the sample loop, and we'll return here from the manual menu to the run menu here. All right. So you see you get our green start button here. Now all we need to do is press start, and it will initialize, and purification will begin.
We've gone through these steps here. We've prepared our buffer. We've started the system. We've primed and purged the system, and then flushed the system, right? Remember, it's in 20% ethanol. We flush that out with water, and then we'll flush the water out with our buffer that we're going to be using during the purification. We've calibrated our pH electrode, and we equilibrated the system, or the column specifically. When you think about equilibrating, it's the column that you're equilibrating. We've set up a chromatography protocol. I showed you how to set up the protocol and begin the run, and then do some monitoring. And then at the end, we'll always want to remember to shut down our system. Once I've flushed the entire system with water, I'm going to flush it with 20% ethanol. What we'll do is just hit the hard switches on our pump, our maximizer, and then our fraction collector. And then the software will start to recognize that the different modules have been powered off or disconnected. So I'm Jeremy Garza. This has been the general operation procedures for running the Biorad Duoflow FPLC system. And if you're new to these systems, I just want to remind you one more time to don't be intimidated by them. There's a lot of tubing and parts here, but if you keep in mind and keep track of where your mobile phases are entering the system and flowing around the system and exiting, either at the fraction collector or the waste container, it will make the learning process that much easier. And good luck on your purifications.